This is one of the very few times in my career that I almost don't know what to say. Listening to the last two panels, I felt like I wanted to jump up on the stage and said, yeah, but, you know, there's so much more to the story. And at Ingenu, we have set out to establish a new standard that will truly change the world. Not a big goal, right? We talk about standards, we talk about 3GPP. The way to create a standard is to build a standard and build it globally. Just to give you a little bit of idea of who our company is, we've been around since 2008. We were on-ramp wireless. We rebranded to Ingenu, which means simply genius. We did that in the fall. And because we wanted to take a complete new direction with the technology that we had established and the foundation that we established throughout the world with private networks all over the world. And just to give you a little bit of idea of who's involved with our company, on our board we have Andrew Viterbi, who's one of the co-founders of Qualcomm, who invented the chip and the reason we're all sitting in the room today. It was good to hear Doug talk about Verizon's success in the IoT space because Dick Lynch, who was the first person to stand up and say LTE is the future as the CTO of Verizon for 30 years, is the chairman of our board. Ivan Seidenberg, who was the CEO of Verizon for 26 years, serves on our board. And they were three of the key people that said, LTE is the future of this. What you hold in your hand is the future. It's all about human communication. And 2G wasn't good enough, and 3G wasn't good enough, and 4G isn't good enough, and we're already hearing 5G's coming, and 6G won't be good enough eventually either. But in the machine world, we need an entire, completely different perspective. An entirely, completely different ecosystem. Machines want stability. Machines want longevity. I'll talk a little bit about some of the things that were mentioned on the last panels. I get deeper into my presentation, but you know, we all grew up going out in the yard in the summer, trying to drink out of the hose. You had your little hose out there drinking. This is the hose that they're asking our machines to drink of from today. I don't know how many of you would like to drink out of that hose. I wouldn't want to get near it, let alone drink out of it. The vast majority of machines don't need to get anything near this. And so we'll take a little trip down memory lane here. Let's see if the clicker is going to work. Maybe, maybe not. There we go. So I will liken this to 2G technology. The automotive industry started pretty simply. Then we got much more complex, and we moved from 3G to 4G. Now we're going to be moving to 5G. All the infrastructure to move vehicles around the world. We're now talking about autonomous driving and taking people out of the loop through technology. But the bottom line is all the infrastructure that has been built out there has been built around the automobile and has been built to get bigger, faster, better. More cars, more speed, more efficiency. Now it's about more fuel efficiency, lessening traffic, doing everything we can. It's the exact thing that is happening to the wireless industry. Now the cities are going in the other direction. They want to become bike-friendly. People just want to get from here to there. They don't want to go 50 miles. They want to go a few blocks. You have entire cities spending literally billions of dollars on infrastructure to simplify the city, to go back to where they can use bicycles and get people around and get as many cars off the road as they can. You look at some of the cities in the world that are just great places to live, are very, very bike-friendly. This is what needs to happen also with our wireless world. Because the machines just need to get a little bit from here to there. We're not talking about having to go 100 miles at 100 miles an hour. All we need to do is a little bit. Thanks to James Brem's research here, we can look at the fact that the vast majority of machines in the world transmit very little data. The question came up earlier, what are we going to do when there's 100 million machines on the U.S. network? Who cares? 100 billion machines on the U.S. network will use approximately the amount of data of about 10 million of these. Machines in the IoT world, the vast majority of them aren't going to create network congestion. They're going to become the victims of it. If you look at this chart, you've got 86% of the devices deployed in the world today use less than 3 megabits or less a month. That is the world. That's the world we live in. I don't believe that percentage is going to change. I think we'll move to 100 billion machines and 500 billion machines, and ultimately, a few decades from now, there'll be 1 trillion machines. But you're not going to have 86% of the devices using gigabits a month. The vast majority of machines will use small amounts of data. Listen to the solutions that were talked about in both of the panels that led up to my discussion here today. And almost everything that was discussed was low data use applications. That is where all the meat and potatoes is now. That's where everybody's making money. And I know about high-speed data. I mean, when we ran Rayco Wireless, we had the biggest data hog on the planet. We ran Audi Connect. We had cars using 3 gigs a month. We know how to support high-speed data and lots of it. But that is a small, small fraction of what is going on in the IoT ecosystem and universe. So as you start to look at it, you start to look at what needs to change. So you look at the people that started the whole CDMA world and a lot of the engineers that were involved with that. They looked at what's happening on the human side and the evolution from 2G to 3G to 4G to 5G and beyond. And they realized that everything that was happening on cellular was counterintuitive to what's going on with machines. One of them is battery life. We had some interesting statistics shared on the last panel. 2G battery life was about 2 months, LTE's about 2 years. Now there were some promises made up here about LTE 0. Oh, sorry, that's already dead. LTE 1, no, we're skipping that for LTE-M, and we found out today it's LTE-M 1 and 2. So take your pick, take your flavor. The evolutions are coming faster than we can figure out. In the meantime, your machines are screwed. Okay? What you need is battery life today. RPMA is the technology that was developed by the engineers from Qualcomm that started our company. And it took all the physical principles of cellular and turned them 180 degrees on the laws of physics, another direction, and said, what if we did this? What if we did this? One of the things we would get is 20 years of battery life. So what could you do with 20 years of battery life? You could change everything in complete, entire verticals. There are verticals out there today that cannot exist because there isn't power where we need it. We talk about water management. We talk about agriculture. We talk about asset tracking, the oil and gas industry out in the middle of nowhere. Not only is there no cellular coverage because it's white space, there's no power either. So power is a huge, huge issue, and you heard it talked about in the last panel. But RPMA delivers 20 years of battery life today. Not in 2020, which is every MNO that I've spoken to believes LTE-M will be ready in 2020, because it's not ready yet. What are we going to do in the meantime? And will we actually be able to get the battery life that they're talking about? I don't know. I do know what we believe, what we understand comes today. Then you start looking at cost to build networks, cost for infrastructure. You've got CapEx and OpEx. If you start looking at what it takes to build an LTE network or for what it takes to build an RPMA network, it's a whole different ballgame. If you're in a dense urban setting, you can get about a square mile out of an LTE tower. We're lighting up a network in Phoenix, the second largest city in the United States by geography, second only to Los Angeles, with 14 towers. There are tens of thousands of cellular towers in that marketplace. We will cover every inch of it with 14 towers. In the rural areas where you're trying to get coverage for water management and agriculture and all these things that have been talked about that are critical to the growing changes and needs that we have, not only in the U.S., but globally, you need massive coverage out there in the rural areas at minimal cost, because you're not going to be able to afford a business model that's got $80 ARPU cell phones running all over there. There's no people. You're going to put it on vegetation and water monitors, your air quality monitors, cattle, whatever else. There aren't people. So you have to be able to justify a cost model, and over 300 square miles of coverage out of one single tower is the kind of cost model that will work. And by the way, that's one piece of equipment the size of a shoebox on that tower. Very simple. Ingenu means simply genius. Everything we're doing is about simplicity on a level that's never been approached in the industry ever before. So you want to have the right coverage, look at the difference between LTE and RPMA. And you can do an overlay there with Sigfox and LoRa too, and they're a little bit bigger than LTE, but they don't approach what RPMA is. But it kind of fits in with most of the discussion in the last panel. So another issue is network priority. I mean, I don't know how many were at the football games over the weekends and tried to use their cell phones. My guess, they didn't work too well. Drive time, prime drive time when you're driving down the road, I don't care what anybody says, you have a lot of congestion. You have a lot of call blockage. You know, if the $80 a month guy with his multi-gigabit plan can't get through, what do you think the chances are of your machine getting through? Oh, well, that's Cat LTE M.2, which will be here sometime next decade, and that might work if there's a tower there, especially in the white space. This is a huge, huge issue. We are talking about changing the infrastructure of the world. Entire industries are changing as they connect. The Internet of Things is the Internet of everything. And industries will change permanently based upon the connectivity and the technology that comes to them. If they cannot communicate with their infrastructure, their business is down in many cases. Some cases, they can just wait. It can go store and forward. It can sit there for an hour or a day waiting to get through. Fine. But if there's a lot of congestion and you can't get that connectivity and you can't get that information, it's a huge problem. And I can tell you that the hundreds of billions of machines aren't going to get priority over the high ARPU cell phones that people have in their hands. So we're talking about, prioritization on networks. Why not a network that's completely prioritized to nothing but machines? It's not about voice. It's not about high bandwidth. It's not about video. It's about everything else that the machines do out there. And that's the most key network priority, is have a network built just for that. So then you start talking about transmission frequency, and you get the throughput and everything, and everybody goes, oh, but what frequency are you on? You're going to have congestion. You're going to have interference. You're going to have all these challenges and all these problems. Well, if you know that before you engineer it, then you engineer so you don't have that problem. We have 38 networks running on the world today. Many of them are utilities, the toughest customers on the planet. That was mentioned in the first panel. Some of those are running nuclear power plants, so you want to talk about security. We're running private networks that are very secure. We are running networks for entire countries that are multi-purpose. We are running networks in the most densely populated places on the planet, like Tokyo and Seoul, Korea, and Los Angeles. And if you do not have technology that can overcome what's happening in that frequency spectrum, and you can't handle interference and congestion, you're screwed. So it's absolutely imperative that you have the technology that can overcome those challenges. The next thing is network evolution. We couldn't have had a more perfect example of it than the previous discussion. We all want to drive down the road. We want to drive down the road every day, and it seems like everywhere we go in America, and it seems like it's that way everywhere else in the world too, everything's under construction. As soon as one construction project's done, there's another construction project. All we want to do is get from A to B, but everything's always, always changing. It's a huge, huge problem. In the machine world, we want stability. We want to deploy it and forget about it. We want the network to be here in 10 years, 20 years, 30 years. We want the battery to last 10, 20 years, as long as possible. All we want to do is deploy it and make it work. We don't want to have to go out and go, oh crap, AMPS is gone, let's go to 2G. Oh, sorry, 2G's dead. Can't activate anymore. Matter of fact, we're turning it off. 3G's right behind it, but 3G was the answer. A couple years ago, LTE was the answer to everything in the nirvana for everything that's going to happen in the future. Well, guess what? We now know that 5G standards are being adopted. They're not ready yet, but they're coming. And LTE really doesn't work for machines, so we're going to come up with a new standard for that. Every time you do that, you throw away your infrastructure and you start over. It's killing the IoT ecosystem at just the point where we're hitting the critical mass of the solutions really work. The sophistication is there. The devices are there. Everything is there. But that thing that you need to make everything work, connectivity, just keeps getting ripped away, and changed. And it's not going to stop because this is more important. And let's face it, if I was still in the cellular industry where I've spent most of my career, this is a heck of a lot more important than this thing. Because at $1 versus $80, I want to sell a lot of these. But if you can purposely build and engineer everything for this, so none of this matters, ever, and never will matter, then you've changed the entire paradigm, and you can create an ecosystem that's built for the purpose of the Internet of Things in a real-time way. So, is there a place for LTE? Heck yeah. The top end of this market on data usage, LTE and whatever is 5G, 6G, and 7G are going to rule the world, and they're going to rule it for decades to come. Whether it's video diagnostics, infotainment, voice applications, whatever, security management, video security. There are many applications that LTE will always, or whatever replaces LTE, will always be the answer for. RPMA will never be the answer for this. But that's okay. We just want the other 86%. And that's where our focus is. So I go back to the premise that I started with, and that is, when it really comes down to it, all we need is something simple, something stable, that will be there for years to come, that will allow us to build an IoT infrastructure and depend on it. People talk about smart cities. We've built smart cities by going in, helping them with one underlying application, whether it's gas meters, electric meters, water meters, streetlight monitors, whatever it happens to be. And then it becomes a multi-purpose network. And now we'll be building public networks globally, and we will have some announcements at Mobile World Conference about how globally that is. But there are some huge impacts coming to what we're talking about doing here today. Because when it really comes down to it, what the machines want is that stability, one communication standard. And the standard will be created by one device that can work in every country on the planet with one module, one antenna, one radio. That is absolutely simply genius, and it's what Ingenu's all about. And I've got a couple minutes for questions. So, thanks.
Round of applause, you white people. Are there questions? Yes, one here. Thank you.
Hi, my name's Tim from Teasel. We're one of the guys that's on the ground actually deploying stuff. We've got over 2 million devices running. We're deploying 30 to 50,000 a month for different applications, and a pretty broad range of applications. We're looking at the radio spectrum opportunities out there, LoRa, Sigfox, or Ingenu. We're trying to figure out how to pick the right application for the right comms backbone for the right application. We firmly believe that the cellular networks are problematic for the M2M space for all the reasons that you've mentioned. So help me go through that decision process and figure out what to use for what application.
Great question. I would look at my application and say, what do I really need? Do I need uplink and downlink? How much throughput do I need? How proven is this technology in this ecosystem? Those would be some of the real key questions. As we've gone around the world and shared our strategy of what we're going to do, we begin to license countries around the world to build networks, whether MNOs or other infrastructure providers that we're talking to. They are doing an analysis of all three of us. Basically, there's three: Sigfox, LoRa, and us. And those are the things that they look at. What's the uplink? What's the downlink? What's my total cost of ownership? How many towers do I have to put in a coverage area? Do I have to put one? Or do I have to put 10? Or do I have to put a few hundred to cover the same square footage, square acreage, square hectares, whatever it is you're measuring. So that is a huge differentiator, and I wouldn't bring it up if we weren't the best. So there's the answer to that question, but you can check it out. Uplink and downlink is critically important. I've been in this industry for 15 years. I never supported an application without a downlink. You always want to talk to the device. You always want to change what you're communicating. You want to maybe do a firmware update. Just change something as simple as how often I want to get that information, either more or less. The simplest of things. If you do not have a true downlink that will do what you need to do, your device is a brick. You do not have a smart device, you have a brick. So that's another key piece of the equation. The other thing that I did not mention is we have 32 patents that protect the entire ecosystem. That's critically important. Everybody's, oh, wow, that's a closed ecosystem. Well, guess what? I can guarantee my customers that the network will be there in 10 or 20 years because no one's going to take any equipment away from us or that's licensed to somebody else or end of life some technology that someone else owns. We own it. We license it out to companies to use it. But we can guarantee that those networks are going to be there for many, many, many years to come. Does that mean we're never going to improve our technology? No, we're already on the 4th generation of what is RPMA. But 100% of what we've ever built, designed, and engineered is backwards compatible to the very first device that was deployed quite a few years ago for San Diego Gas and Electric, which was the first large deployment that we had of a private network. Did that answer your question? Okay. Check out our website.
Okay, next question.
Thank you. This is Mo Nasser from Sprint. Hey, John, how you doing?
Good.
You actually answered part of the question that I was going to ask about the evolution of RPMA, because you talked about the paradigm for 1X and EVDO, and then so you must have the same paradigm. But so would there be changes that in the hardware, just like we have to do? And what are the price ranges of modules that would actually fit in within RPMA versus LTE?
Great question. Our changes are not about bigger, more and more data. Again, we are going to focus where the machines live. So we do not have to end-of-life things to get there. Our generations are about making our chip a little bit faster and a little bit smaller and a little bit cheaper, to head into your next question. We are looking by the end of the year at module pricing in the $5 range. So it will be competitive with 2G and it will crush everything else that's in the cellular world.
John, my audience has gone quiet on me.
That's okay.
Okay, going once. My wife says I need the exercise. Somebody in a corner somewhere should raise their hand vehemently right now.
You got like 1 minute. There's one.
There
you go. He's going to make you run, Carl. You can do it. Actually, there's another one over there too, so you're going to have to run.
I'm just going to ask you to finish the discussion on the pricing side. Communications, tower costs. What's the overall infrastructure cost to deploy this technology?
For me to deploy a certain amount of square footage, and I'm not going to get into it on this stage right now. We have some white papers on our website that will give you all the specifics. But what I spend $30,000 to build, the cheapest a cell carrier can cover it for is $3 million. For the exact same square footage. Exact same. So 30,000, 3 million. OpEx is coordinating the same way. Okay, you got less towers, less infrastructure, your OpEx costs are lower. So we have the ability to be much more aggressive in the pricing for MRC and data usage because the front end costs are so much less.
Hi, can you share with us some of your partners that you're putting together for the infrastructure in terms of module suppliers or chip suppliers?
Chip suppliers, today we have one, and we will keep one for the immediate future. Module suppliers, today we have one. However, we will be announcing a handful in the coming months, and I'm not prepared to announce them here. But the ecosystem is growing very, very quickly. We have SKUs already available in anything that has to do with utilities, energy, oil and gas, city infrastructure, whether it's light monitoring, signal monitoring, asset tracking, asset management, all of that type of infrastructure. There are actually SKUs available today, and it's literally growing constantly. But today, at this point in time, one chip, one module. We will keep one chip for a while, just because our objective here is to drive that cost down as much as absolutely possible. But we do want to have multiple module suppliers.
And with that said, John, is there any closing statement you want to make?
Oh, we're just happy to be here. It's been around this industry for a long time. It's exciting to see the inflection point that I believe we're at now, and it's fun. I mean, we'll have the Super Bowl here in a couple of weeks, and I guarantee there will be commercials in the Super Bowl that talk about the Internet of Things, and no one could have imagined that a couple of years ago. So it's fun to be here.
A round of applause, please.